We're going to attempt to record in second block today since we've had trouble, technical issues. I don't know if you've checked School Fusion, but the last two videos haven't worked. I've recorded, and then as I try to make the recording happen, it just kind of corrupts and stops. So I'm going to, please remind me, guys, at 8:45, no matter where we are in the notes, I have to stop this, okay, the recording part. I might still talk, but I have to just be able to get it to make a video before we have to leave. So we're going to talk more about correlation today. You are going to absolutely need your formula sheet and a calculator. So if you don't have either or both of those, please get them out for me. We are going to specifically look at some formulas, being able to use the calculator, and find out what we're going to do with the lines of best fit. Now, I have put up a scatter plot. Yes, ma'am. So if you were not here last class and need a formula sheet, that's going to be an important thing. So you'll find them at the bottom here of my cart. Come grab a page protector and a formula sheet because you absolutely will need both of those things. So I put up a scatter plot here about fat content versus protein on the Burger King menu. Okay? I know, right? Julissa had the same face I had when I saw this graph. I'm anti-fast food, personally. Chipotle, I will do. That's about it. Chipotle, because they do, Chick-fil-A is, no, ooh, no, lunch meat is disgusting. Slimy, it's gross. Sorry, I'm just like weird. I don't know what to tell you. I will do like natural, whatever. Chipotle I can eat. I'll eat a Chick-fil-A milkshake. I ate Chick-fil-A the other day. I will eat it occasionally, but Burger King makes me want to vomit. I'm just telling you straight up, okay? But that's just personal opinion. I am not being paid by Burger King or whatever, or McDonald's for not making you go. I'm just kind of showing you here a relationship, okay? Now, we know right away, based on what we just said with lurking variables, and we know about correlation and causation, that protein, and the amount of protein in a food menu item is not going to cause the amount of fat. Turn the lights out so y'all can see. Yeah. Better? Okay, thank you. Sure. So we know one does not cause the other to happen, but we're going to go ahead and we have 30 menu items, and we're going to kind of investigate this scenario throughout what we're going to do today. Okay? So what if you were going to describe this situation? Tell me what you would just, what words would you use to describe it? I just said some key words. It's bivariate data, not univariate. When I say describe univariate, you're thinking socks. When we're thinking bivariate data and I say describe, you're thinking, right? Form, direction, strength. Okay, form, direction, strength. So we're going to say what? We think it's positive. We think it's linear. And we think strength we don't really know. Okay, could we estimate it? We could estimate it. What would you estimate it to be? 0.7, 0.8, somewhere around in there? I would agree. Something around, we're not sure. What if we just said moderately strong? I don't think it's really strong, do you? Moderate. I would say moderately strong is fine. And again, the scale of the axes can really skew your viewpoint. You can make the scale very different, and it would look either more linear or less linear depending on the scale that you use, correct? So that's going to be an important factor. You can't just look and say it's definitely or moderate or whatever. It's an estimate, really, without what are we looking for to answer strength more clearly? What number do we need? We would need the correlation, right? And we don't have that yet. Okay, good. So we know how to describe the linear model. We're going to try to find the equation of the line of best fit. There seems to be a positive linear association. I'm going to even say a positive linear association. We need to find a model. Okay, so we're going to do that, and the model is just an equation of a line that goes through the data. We talked about this last class. And we're going to be able to, the linear model, once we get it, we're going to use some words to help us relate the two variables. Okay? So we know fat content and protein are the two variables we're looking at here. So we know this formula. It's on your formula sheet. I believe it's the fourth formula down on your descriptive statistics column in your formula sheet. Remind us, just from what we learned last class, since there were several people out, what B0 means. That's the y-intercept. Very good, Nicole. Y-intercept. And then what does B1 mean? It's with the x, true, but what does B1 mean? It's the slope. Good. And we're going to actually interpret what these two things are in the context of the problem here in just a minute. And that's going to be important because you're going to have to do that not only on your homework tonight, but you're going to have to do that on a quiz or a test in the future as well. So I'm going to ask you, and remember, remind those people who were out last class, we don't use y's and x's. What do we actually put in when we write the equation? The actual variables, okay? So in our particular situation, when we look here, what's our x and what's our y? The y is the fat content, and the x would be the protein. So in our case, we're going to be looking at trying to fill in thank you. Okay? So we're going to be filling in these numbers. Would you agree? We're going to be filling in the slope, and we're going to be filling in the y-intercept. If you look on your formula sheet, you will see that you have formulas for both B1 and B0. Do you see that? The next two formulas on your formula sheet are listed there. Okay? So those, again, are ones that you can always use. You can use this formula sheet anytime you want. But let's look at how we would find them. Let's start with our B1, which is our slope. So on your formula sheet, it says this. B1, or our slope, is R. What's R again? Correlation. So I know that this is the correlation. This is very slow for some reason. Weird. All right, so it's the correlation. And then, any guess as to what SY and SX stands for? We've used the SX notation before. Do you remember? What was it for? The sample standard deviation. So we have two variables. We have a fat content and we have a protein content. We have an X and we have a Y. So we can actually find the standard deviation of each of those individually. Treat them as their own little univariate data sets. And that is what those are. So this is the standard deviation of the Y variable. And in our case, that was the fat. Would you agree? And then this one would be the standard deviation of the protein. So if we were just given two columns of data, okay, if we were given all of the fat content and all of the protein content, okay, for each of the items, we could find the standard deviation of each of those individually. We know how to do that on a calculator, correct? We could just go ahead and find the standard deviation of list 1. Find the 1-bar stats of list 2. Okay, we can do that. We know how to do that. So these are all numbers we can find. Okay? If you look at the next variable, or the next thing, is B0, and that's the next formula, I believe, that's listed. Making sure that it's still, if this doesn't turn red anymore, let me know. That means it went out, okay? It just wasn't charged enough. So B0 stands for the slope. No, I'm sorry. It does not stand for the slope. It's the y-intercept. We just did the slope. So the y-intercept is B0. And let's see if we can pick apart what's in the formula. Notice that it has the slope in it. That's not the slope. The B1. Isn't that the slope? So we would have to find the slope first. Do you agree? So we find the slope first, and then what is x bar, y bar? The mean. So again, we have we have a fat data set, we have a protein data set. Now they're a matched pair, but we can treat them individually. We can find its own standard deviation and mean, and its own standard deviation and mean. So this is just going to be the mean of, I believe protein was our our x, and this would be the mean of the fat content. Okay? So we have two individual, well, they're matched, one matched pairs of data set, but we can treat them individually and find their own standard deviation and mean to be able to find the slope and a y-intercept. And that's really all we need to write an equation. Okay? So I'm going to give you one that's not related to the Burger King problem, but it's going to be one like you're going to see again, so I'd like to try it. Can you guys see that? Is that big enough for you to see in the back? Make it a little bit bigger? Better? Okay. So this is just an example. I'm giving you some of the information, and I'm asking you to write the equation. So I'm asking you to find the regression equation, the y-hat equation. So I need to find your y-intercept. I need to find your slope. Which one should we find first? Look at your formulas. We just went over them. We have to find the slope first because the y-intercept requires a slope, doesn't it? So let's do that. Let's find the slope first. The formula, double check me, I'm just going from memory here, is this. Is that correct? You have your formula sheet, just double check it. Now let's look at the problems that I'm given. Am I given all the information that I need? I'm given R to be 8, and I'm given the standard deviation of y is 11, and the standard deviation of x is 20. So use your calculators and tell me what you get here. It's going to be a fraction, and I want you to leave it as a fraction, not a decimal. 88 over 20 reduces to be 22/5. I'm just doing it in my head. I don't know. Is that right? You guys know you can just put this in and go to math frac and it will automatically reduce it for you if you want an easy way out. Or you know that this goes in it. Anyway, whatever. All right, so I found the slope. What's my next step? The y-intercept. So let's do that next. So the y-intercept formula is, look at your formula sheet. Your y-intercept is going to be y bar minus the slope times x bar. Do I have all the pieces I need to answer the question? Sure, so let's plug it in. So I'm going to plug in y bar to be, oh, there it is. Oh, 8 is also the correlation. Interesting. All right, so I have 8 minus 22/5 times x bar, which is 40. I'm going to trust you with your calculator. Well, I have a calculator too, so I can do that. Somewhere. There it is. Come over here. All right, so I don't have it anymore. Anyway, it went away because it's too big. But tell me what you get. I trust you. Negative? Is it okay to be negative? Sure. Y-intercepts can be negative, can't they? Of course they can. Negative what? Exactly? All right. Negative 168. Okay. So at this point, I'm going to put it all together and write my equation. Okay. So I'm going to say that my y hat is equal to negative 168 plus 22/5 times x. Now, we don't have a context here, so we don't have fat or protein or any words to put into our equation. If we did, I would want you to put that in there. Okay, this is just straight calculations. This is just algebra. Plug it in. Can we do that? I have seen on almost, I shouldn't say on almost all because I haven't seen them all, but on quite a few of released AP exams, there's at least one multiple choice question where you have to use the formulas. Okay, so it's going to be there. They're there. You have them on your formula sheet. It's good. Yes, ma'am. Oh, the one up top is one that you'll never use. Okay? Yeah. There's some things on here that I'm not sure why they continue to be on the AP exam formula sheet. But yeah, that first one, that B1, did you hear Nicole's question? If you look higher up, there's another B1 equation that has the sum and all of that. I've never used that one before. Okay? Okay, let's try another one. This one's a little bit different because you're given the equation and you're actually asked to go back and find the standard deviation of the y and the mean of the y. So how am I going to be able to answer this question? Tell me what I should do here. I'm still going to use the same two formulas I did before. It's just that, come on, it's just that this is the B naught and this is the B1. Would you agree? So I'm given some information just kind of in a different format, that's all. So which one do you want to find first? Doesn't really matter. SY? Okay. So which of the formulas, is it the slope or the y-intercept that deals with SY? What's that? B1, right? So if we're going to find your slope, I'm just going to write the formula that I'm using. Do me a favor and do that for me as well. Tell me what formula you're using before you use it, so I know which one you're plugging it into. Okay? So we know what B1 is. We know what our correlation is. We're trying to find SY, and we're given SX. It's a matter of now just solving for the variable that I need. I want to find the standard deviation of the y variable here. So, algebra. Do we remember? Christopher, wake up for me, love. How do I solve this for x, or for the variable, I should say? How do I find the standard deviation of y? Tell me the first thing I should do. Do I want to get rid of the negative 0.4 or the 5? Okay, it doesn't really matter. You could do either one. Multiply both sides by 5 and divide by negative 0.4. Would you agree? It doesn't really matter which order because you're not adding or subtracting anything. So you can do either one. I'm just going to use Anna's calculator here. And I get 4. Double check my arithmetic. But I get that the standard deviation of y is equal to 4. Did you get that as well? I divided by negative 0.4 and then I multiplied by 5. Did I get it wrong? Oh, that's because I multiplied by 0.4. Yes, that is not right. Let's try that again. This is why I need you in my lives. Negative 2 divided by, I just hit multiply again, but divided by negative 0.4, and then times 5. I also got 25. That's much better, don't you think? So 25 is the correct answer. I'll go ahead and show you what I did. I multiplied by 5 to get rid of this 5, and then I divided by negative 0.4 to get rid of that. Okay? The next thing I want to do is to be able to find y bar, or the mean of y, and that requires this formula. Agreed? So I'm just going to plug in what I know. 190 is equal to what I'm looking for. B1 was negative 2, and x bar was 10. So 170? Double check my arithmetic. Negative times a negative is a positive. Subtract 20 from both sides, and I get 170. Yes, love? This right here? That one? Are you sure? Yeah, parenthesis, parenthesis. This is just algebra. Being able to know what formulas you need to use. You have the formulas to use, plug and chug. Okay? It's really nothing more than that, being able to use these formulas. Okay? How are we doing so far? We haven't gone to interpreting yet. We're getting ready to do that piece. So the context piece is coming. It's just not here yet. All right, so let's go back to our fat protein example. And I have a scenario. Let me try to make it a little bit bigger. so we can see in the back. Okay? This is an important piece. I want us to look at this for just a minute. I'm giving you the equation. I'm telling you what it is. Okay? That's the regression. Tell me how I know just by looking at the equation that it's a regression equation, that it is the line of best fit. There's a symbol that tells me that. What is it? The little hat thing above the word fat. That, it's the caret. Good. That, we call it a hat in statistics, but it is in fact a caret. I agree. The fat hat, sorry, the hat on there tells me that it is a regression equation. I want us to look at the numbers, and I want us to interpret their meaning. Okay? And this is an important question, and I guarantee you'll see this question on future assessments. Okay? I want you to interpret the meaning of 0.68. I'm sorry, of 6.8. Of the y, I'll just say of the y-intercept. And we're going to interpret the slope in a minute, but let's start with the y-intercept. What is the meaning of the y-intercept? Let's think about the graph. Where is it on the graph? Somewhere about right here, would you agree? It looks like it might be 0 there, but it's not. It's 6.8, okay? So we're going to say 6.8 is the y-intercept. What's the meaning in context? How much protein versus how much fat? If there was a menu item that had how much protein? 0, right? If there's a menu item on Burger King's menu that had 0 protein, how much fat will it have? 6.8. So that's what we're going to say. Okay? The meaning here is going to be, because we're really predicting. It's a line of prediction. It's on the line of best fit. We're using it to predict. So we can say, I predict that a menu item with 0 grams of protein will have 6.8 grams. Oh, wow. Helps if it goes to 6.8 grams of fat. That is the meaning of the y-intercept, because it has 0 on the x and 6.8 on the y. And we're using the words fat and protein. Okay? Now let's interpret the meaning of the slope. That one's a little bit harder. I'm going to get to this prediction thing in a minute. But let's come back to this. I'm going to circle it. We're going to come back to it in a minute. Okay? Let's interpret, let's use blue since we don't want to get it confused with the green. Let's interpret the meaning of the slope. Now we have to really think back to our algebra skills, and we need to think about what the slope is. The slope was rise over run. What does that mean in terms of y and x? It's a change in y over a change in x, right? So just kind of refresh our memory, change in y over change in x. Let's put context to that. What was the slope here? 0.97. 97 over 100. Can we convert that to a fraction? So we have that, okay? So that means, you ready? For every, so again, we're using 97 over 100 as our slope. 0.97. We're converting that decimal to a fraction. So for every 97, and that's the y, correct? So for every 97 grams of fat, comma, How many grams of protein will there be? 100. We're taking the slope, we're making sure it's written as a ratio or a fraction, and we're interpreting and putting in the variables, the context of our situation. So we're putting in the fat, we're putting in the protein, and we're making a sentence or meaning out of it. Okay, that's the ratio, that's the relationship. For every 97 grams of fat, there's going to be 100 grams of protein. If we could reduce that, we should. I don't think it can be reduced, though. Okay? But interpreting the meaning is important. It is something you will definitely see again. And we'll practice some of that today, or later on in a few minutes. Yes, question? This right here? Yeah, this is something totally different, and I wish I could have just taken it out and moved it to a different problem. Yeah, so what I'm about to highlight is a totally different problem. So we're going to come down here and deal with that in a minute. Okay, thank you. That's something totally different. Only thing I would give you is the equation of the line and say interpret the slope, interpret the y-intercept. That's all you're going to be given. Okay? Another question, go ahead.
For the top problem,
Is it the meaning of the y-intercept? Uh-huh.
Is it always going to be 0?
Yes. Y-intercept, the x is always 0. Good question. Yes, ma'am. Noel.
So when you're talking about slope, like putting it in that fraction, it's always going to be out of 100, right?
Well, I did it out of 100 because it was 2 decimal places, hundredths. If it was 1 decimal place, it would be over 10. 3 would be over 1,000. So just taking that decimal and just converting it to a fraction. Okay? All great questions. Anything else? No? All right, let's look at this highlighted yellow question. And it really should have been down, and I apologize. The predicted fat content for a BK broiler chicken sandwich that has 30 grams of protein is? Well, if I'm asking you to predict, that's the key word, predict. Predict means I'm going to take the number given and I'm going to plug it into the line of best fit. Because when you are asked to make a prediction, you use the equation. So I'm going to take the 30 grams of protein, I'm going to plug it in up here into my formula, which is what I did here. 6.8 plus 0.97 times 30. I just plugged it into the equation. And I get a predicted value of 35.9 grams of fat. Broiler chicken. Broiler meaning healthy. Not exactly. I'm going to get sued by BK. The king is going to come in here. He's scary, by the way. He freaks me out like a little too much, I think. Shiny, yeah. He's like his plastic face, I just want to punch it. I don't know. I don't really want to punch it. It just like freaks me out. It makes me scared. Okay. Like I have nightmares to be behind like my shower curtain or something. Ah, there he is. How do we feel so far? You feel okay? Can you use we're going to practice. Can you use the formulas? Can you interpret their meaning? Now, what I'm going to give you, okay, is a problem, and it's going to be the context is a monopoly set. Okay, so I'm going to ask you some questions. Is there an association between the spaces from go on a Monopoly board and the cost of the property? How many of you have ever played the game of Monopoly? Everybody should have hopefully played. Hopefully. If not, maybe we'll play one day. It does take forever. I have Muttopoly. I need Bulldogopoly. All right. But if you've ever played the game, shh, folks, quiet please. If you've ever played the game, you know that the very first spaces you come to are the cheapest spaces. And then the further you go around the board, the more expensive they get. Park Place is the most is expensive. Boardwalk is the most, and it's the furthest property around the board. So another one, sorry. So what I'm looking at is a series of questions. And obviously, you're going to have to do these on another sheet of paper because there's just not enough room here. First thing I'm going to ask you to do is to create a scatter plot of your bivariate data. And by the way, I'm going to pause this recording because I think we're about done here. Okay? So, Monopoly, and then I will assign problems, check School Fusion for textbook problems to look at.